Hello world, Noah here, and welcome to Lab 6. This is the lab for the Booleans lecture, and in this lab we're going to practice writing some Boolean conditions. So I have a couple of puzzles here. We're going to work through them one by one. Basically I have a condition like this written out in English, and then I have some variables defined, and then we need to write the condition that will be true or false as appropriate based off of what we have in English. So we're basically translating from English into code, which is obviously an important skill to have when you have, some algorithm idea or some idea for a line of code and you need to actually express it, in Python. And so this is good practice. Let's start with the first one. This one should be pretty easy, and they'll get more difficult as we go through. So we have two integers a and b, and we want the condition is a is strictly greater than b. And by strictly greater, I just mean that a is not less than b or not equal to b, right? So a is greater than b, it's not less than b, it's not equal to b. That's all. And so we have a and b, and we want to write this condition. Well, this one's easy. It's it was on the slide. There's nothing special that we have to do here. The expression is just a greater than b, right? If we said, here we say greater than or equal to b, you would of course say greater than or equal to. But there's really nothing to this puzzle. Now, if we want to, test this out, we can't just write a greater than b, because that's it's an expression. It'll give a Boolean back. But if you want to actually see what the result is, we need to print it out. And so if I go ahead and run this, we'll type in, for example, 5 and 4, and it'll say true because 5 is greater than 4. If we run this again, I'll type in 5 and 6, and it'll be false because 5 is not greater than 6. And if they happen to be the same value, it'll still be false because 5 is not greater than 5, right? If this were greater than or equal to, then it would be true. So that one's really easy. The rest of these are going to be more interesting. But that's a good place to start. So let's just comment this out, and then we'll move on to the next one. So this next one is asking I is even. So it should be true. The condition that we write should be true when I is even, and it should be false when I is not even or when I is odd. Well, I think we've discussed this already in a previous video, as far as how to calculate this. And we even discussed it a little bit in the lecture, not even specifically, but something very similar to this. Basically, the idea is that if I is even, it means that if you divide I by 2, you don't have any remainder, right? And so basically, we just calculate the remainder of I divided by 2, and we ask, is that remainder equal to 0? So it would look like this: I mod 2 equals 0. Right, so notice I mod 2 here is an expression. It's going to give us an integer, and Python's going to evaluate this expression first before it compares it to 0. So you could imagine that there are actually parentheses around this. You don't explicitly need them, but you could imagine that there are. So first we'll do I mod 2, which it'll give us an integer back, and then we're comparing it to 0. And you can compare, I guess I didn't show this in the lecture, but hopefully it's common sense. You can compare, a variable to a constant or a literal, they're called. So you can compare it to this number 0. You could compare two constants to each other, but there's no point in doing that. But basically here we're doing I mod 2. We're saying what's the remainder of I divided by 2? And we're asking, is that remainder equal to 0? Because if it is, then I is even, and if it's not, then I is odd. I'm going to delete the parentheses because they're not required, and I think it makes the code look a little bit cleaner when they're not there. And again, let's just print this out so we can actually see what the result is. In the future after this lecture, we're not going to be printing out these conditions. We're going to actually be using them elsewhere. But just so we can practice writing these conditions and seeing what the result is, we'll do it here. So for example, if I give 4, right, 4 mod 2 is going to be 0, which is equal to 0, and so it'll be true. If I run this again and I type 5, it'll be false, right, because 5 mod 2 would be 1, and 1 is not equal to 0, so this condition would be false. And so again, this was a pretty easy one. I think it's something that we've discussed before in some amounts of detail. But basically, we have this expression on the left-hand side, we have this constant on the right-hand side, and we want to know if they're equal to each other. So that's it. Pretty simple. I think it'll get a little bit more interesting starting now. So we have two numbers, a and b, and we want to say either a or b, or both, are non-negative. And non-negative means it could be a positive number or it could be 0. Right. So if I ask for a negative number, basically 0 is not negative and it's not positive. So if I said either a or b or both are positive, then 0 would not count. Or if I asked if they are negative, 0 would not count. But when you say non-negative, that means that 0 is valid. So basically, if a is 0 or positive, or if b is 0 or positive, then we're good. But we can of course be a little bit simpler with that. Instead of, basically that was 4 different conditions. We only really need 2, right? So if a is non-negative, that means that a must be greater than or equal to, not b, but 0, right? A must be greater than or equal to 0. Basically, we're saying if a is greater than 0, that means it's positive. If a is equal to 0, that means it's 0. But in either of those cases, it's non-negative. And those are all the possible cases for a non-negative number. Because if this condition here is false, that means that a has to be a negative number, right? Then we have this other condition where it's the same condition, right? B greater than or equal to 0. And it's the same exact condition as we had before. And we need to join these two separate conditions together, right? And so here we said either a or b or both are non-negative. And so here we need to use or to join them together. If we said here both a and b are non-negative, then the answer would be and, of course. And you can kind of see, the word or is written here, so we're going to use or. And when I gave the other example, I said the word and, so we're going to use and. So it's really not all that tricky. You just have to think, do we want either or both conditions, or do we want that both conditions have to be true? And that's how you figure it out. And so we can, print this condition out so we can look at it. So, for example, if a is 5 and b is 6, it'll be true, because they're both non-negative. If, let's say, a is 5 and b is 0, it'll still be true because b is 0, but it's not a negative number, so that's totally fine. But if a is -1 and b is 5, that'll also be true, right? Because this condition's false, right? A is not greater than or equal to 0, but this condition is true. And we have this or here, which means that since this condition is true, the whole thing will be true. I got confused for a second there because I thought that I had written and for a split second, but I didn't. And so just to demonstrate the last thing, if both of the numbers are negative, it will of course be false, right? So either a or b or both are not negative. Well, both of these are negative, which means that the overall condition is false. And so that was a good example of a compound condition. Next, S, which is a string, has between 3 and 5 characters in it. So for example, the string hello or world would be fine because they both have 5 characters. The string Noah would be fine, it has 4 characters. And would be fine because it has 3 characters. But long words like Python, for example, has 6 characters, so that we would want to say false. And I think you can probably imagine some words that have 2 or 1 characters, or that have more than 5, if you use your imagination, right? And so basically, we're asking this question, we want to know the number of characters in S, and then we want to know if it's in this correct range. Well, first off, given a string, how do we know how many characters are in the string? Which is to say, how do we know how long the string is? So hopefully you remember this from the lecture on strings, but in case you don't remember it, we have this len function. So if we do len of S, it will tell us the number of characters in that string. So for example, len of hello will be 5, right? Because it's HELLO, that's 5 characters, right? And so given this, we know how many characters there are, and we have this condition that s has to be between 3 and 5 characters. And we're going to say, I'm going to add inclusive, right? So including 3 and including 5. If you don't have this inclusive, it can be, you could say, do we include 3? Do we include 5? You know, it's a little bit confusing. So we definitely want to be very specific, but I'm going to be specific and say we want to include 3 and we want to include 5, right? And so basically, we want to know, we can basically break this up. Instead of saying between 3 and 5 characters, we can say s has at least 3 characters and at most 5 characters. And from there, you can kind of see, you know, the two conditions. So if s has at least 3 characters, it means that the length of that string has to be at least 3. And then if s is to have at most 5, it means that the length of that string must be less than or equal to 5, right? If this said exclusive, if it said to exclude 3 and exclude 5, we would just get rid of these equal signs here. And of course, then the only answer could be 4. But if this were more of a range, you would just get rid of the equal signs there, right? You get the idea. And to fill in this blank, to combine them together, it has to be between 3 and 5, which means that it has to be at least 3 and at most 5, and I keep saying the word and so we're going to put the word and in there, or we're going to use the, you know, the and operator, right, to say that both of these conditions have to be true. If we used an or there, that means that either the string has at least 3 characters, or it has at most 5, or, you know, it has both. It satisfies both of those conditions. And so that's clearly not, you know, what we want. But with the and, we're saying that both of these conditions have to be true. And so we can actually, we can actually test this out. And so let's test this out. If I type in, for example, the word hello, it will of course be true. Because it's 5 characters, it's within that valid range. If I type in Python, it'll be false because Python is 6 characters. It's not within that valid range. And you get the idea. One thing that I'll notice, or that I'll note, that's a cool feature of Python, is that you can actually sort of combine these two things. Because if you were writing this in, let's say, a math expression, you might write something like 3 is less than or equal to x is less than or equal to 5. And you can actually do this in Python. So you could actually combine these two conditions sort of and say 3 is less than or equal to len s is less than or equal to 5, right? So this looks similar, more similar to how you would write it in math, and this is totally valid in Python as well. So it'll basically check this condition here, where 3 is less than or equal to the length, aka the length is at least 3. And then it'll check this condition that the length is less than or equal to 5. And so I'll just run it with both of these so you can see that they print the same result. But hello, they're both going to say true. You know, for Python, they're both going to say false. And, you know, you can try other strings and, you know, you can see. But the point is that these expressions will both do the same thing. And so this is actually a good little shortcut. If you have usually a number, and you want to say, is this number within some sort of a range, you can use this syntax here, which is pretty nice. And so this is the last one, but I think it's probably the most interesting one. We have a string again, which we're calling s, and we're saying that s must begin with a lowercase a. So for example, the word apple in all lowercase would be valid, but the word banana would not, because the word banana does not begin with a lowercase a or an a at all, you know, for what it's worth, right? And so we need to write this condition. And so how exactly are we going to do this? Well, you have to remember back to the strings lecture. And so we remembered how to do the length thing before, which is good, but this is maybe even a little bit trickier. Basically, we need to access the first or 0th character of this string. You remember we had that table and we said every character in a string has an index or a position number associated with it. And the very first letter of the word has index 0, right? And so the way that we access it is we use, you know, we put the name of the string and then inside of the square brackets we put the index. So if you're reading this out loud, you'd say s at index 0. That's what the square brackets mean, at index. And so if the word is apple, for example, we're saying apple at index 0. The character at index 0, it would be an A, right? And so to say that s begins with a lowercase a means that this character, the 0th character, has to be a lowercase a. And so we can just use, this comparison. And notice that we're comparing two strings, right? You can think of them as characters, but they're technically strings. This is, I guess we've been using numbers for everything else, but you absolutely can compare, two integers, two floats, two strings. You wouldn't want to compare a string and a float because there's no real overlap between them. You could compare an int and a float, and that'll work as you'd expect it to. But the point is, these are both strings, and so you absolutely can compare two strings together. It's not just limited to numbers, right? And so we'll try this condition here, and we'll see if this works. And so we try apple, and it says true. And just to be clear, if I do it with a lowercase, if with an uppercase a, it'll be false, right? Because we said it has to begin with a lowercase a. And we could try banana, and it'll be false, of course, because it does not begin with lowercase a. But the problem with this, and there actually is a problem, is if I choose to not type anything at all. If I don't type anything, it's an empty string, right? We get this error string index out of range. And, maybe you didn't think about this as being a potential issue, but hopefully this error makes sense, right? I didn't type anything. It's an empty string, and I'm asking, what's the character at index 0? Well, there's nothing there because it's an empty string, and so we get this error here that the index is out of range. And so we need to have another condition to make sure that this operation is safe, right? Because basically the problem here is I made an assumption. Maybe I didn't realize it, but I made an assumption right here that there is a character at index 0. And that assumption may not always be true. And in this case here, it was not true, right? And so basically you want to look out for, maybe it's hard to tell sometimes, but if you're making assumptions anywhere, you need to make sure that you handle those assumptions correctly. And in this case, I did not. And so what we need to do is we need to add another condition. And the condition needs to be, well, s can't be empty, right? If s is an empty string, then we want to say false, right? It doesn't start with a lowercase a, but right now we're giving an error instead. So there's a couple ways to do this. You could do this. You could say s is not equal to an empty string, right? Because if s is equal to an empty string, then there's nothing there. You could also say, so you could say s is not equal to, empty string. You could also say len s is greater than 0. The length is greater than 0, or I guess if you want, you could say the length is greater than or equal to 1. I would prefer the greater than 0 instead of the greater than or equal to 1. But, all of these things accomplish the same thing. They say s can't be the empty string. And then to combine these two together, well, s can't be empty, and it has to start with a lowercase a, and so we'll use an and to combine them together because both of those conditions must be true. And so just to test this again, lowercase a apple is going to be true. Lowercase b banana is going to be false. And if I just put an empty string, I don't type anything, now we get false instead of an error message, which is what we want. And just, one more, I guess, a bonus thing is s begins with an a. So it begins with an uppercase a or a lowercase a. And so, well, what do we do? Well, s still can't be an empty string, but then we can have a compound condition here, right? We have this and, which is a compound condition, but we can introduce another compound condition to say, well, s is a lowercase a. We have these two conditions. S is a lowercase a, s is an uppercase a, right? And now what do we want to use to join them together? Well, we can't use and because that character can't be both lowercase and uppercase at the same time. And so, of course, the or would make sense there, right? And we want to use these parentheses because we want, this expression right here should be evaluated before we evaluate this and this, right? If I didn't have the parentheses, Python would evaluate these two things first, and then it would say that or, this expression here. So we want to check, and maybe it doesn't matter in this case. Yeah, no, it would still matter in that case. We definitely want to have the parentheses here, and don't worry about it too much. But basically, this is a compound. We have two compound operators right here. And you could say, well, what if I just do s dot lower, or s at index 0 dot lower, right? And then I just need to check the lowercase a. I don't need to worry. The uppercase a will become a lowercase a. And so that's totally valid as well. So you could also say s is not empty, and s at index 0 dot lower is equal to lowercase a, right? So we get this character, and we convert it to lowercase. So if it was an uppercase a, it'll now become a lowercase a. So this is completely valid as well, but just to give a demo, of this more complicated expression here, we have this compound expression, which is part of another compound expression. So you can combine these expressions together in lots of different ways. And so just to demo that this still works, and it'll print out this original one here and then the new one. So if I do, capital A, apple, this expression would be false, right, because it doesn't start with a lowercase a. But this one will be true because it does actually start with an uppercase a, which in this expression we said it's valid. In this one we said it's not valid. And then, of course, if it's an empty string, it will still be handled correctly in both cases. And so that's all for this lab. We took a look at a couple of these conditions. We got some practice with translating from English to code, which is a very valuable skill to have. And again, like I said in the lecture, this stuff may not seem too interesting at this point. It may seem kind of arbitrary. Why are we writing these true or false conditions? But again, in the next lecture, we're going to actually use these conditions to control how our code runs and how it works. And so then it'll be clear. But I thought it was worth dedicating a whole lesson to Boolean logic because it's something that you definitely want to understand, because you're not going to write a program that doesn't involve Boolean logic unless it's an incredibly boring and simple program. And so yeah, that's it for this one. I'll see you guys in the next lesson. Bye for now.